Hi students, very good morning to all of you. As we are discussing about the lesson which is called chemical bonding, in that we have discussed about the introduction of chemical bond and also about Coase-Lewis theory and about octet rule and significance of the octet rule, how can we write the octet rule, and also about the types of chemical bonds, that is about ionic bond, covalent bond, coordinate covalent bond, and also about hydrogen bond and different types of bonds involved in them. And after that we finally discussed about the hydrogen bond and also the types of hydrogen bond, and also about dipole moment we have discussed in detail about in dipole moment in the previous class. What are the applications of this dipole moment and how can we write the dipole moment for a given molecule. So in order to write the dipole moment, the first thing is we should know the shape of the molecule. How can we write the shape of the molecule? That can be explained by a theory called valence VSEPR, Vesper theory. What is the best abbreviation for that is V represents valency, S represents shell, E represents electron, P represents pair, R represents theory. Valency, shell, electron, pair, repulsion theory, which is called Vesper theory. In this theory, how the shape of the molecule can be determined, how the bond angle can be determined, all the bond parameters can be explained by this theory, which is called Vesper theory. V represents valency, S represents shell, or E represents electron, P represents pair, or represents repulsion. Valency, shell, electron, pair, repulsion theory. So in now today's class we shall discuss in detail about Vesper theory and what are the postulates given by him in order to know the shape of the molecule. So to know the shape of the molecule, some postulates have been given by the Vesper theory. So what are the postulates? Among them, or before going to that postulates, we should have an idea about what are bond pairs, what are lone pairs, and which is called central atom. For example, if we take ammonia, here I have written the formula of ammonia, which is NH3, and here I have represented the structure of ammonia. The structure of ammonia can be written as like this. In this structure, the bond between nitrogen and hydrogen, this is called as bond pair, and the dots which are present on nitrogen are called as lone pairs. So which are bond pairs means which are involved in, if the electrons are involved in bond formation, like this, a bond is formed between nitrogen and hydrogen. These are called as bond pairs and these are called as lone pairs, and here N is called as central atom. So what are bond pairs, what are lone pairs, and which is called central atom? If we know all these things, we can understand the postulates very easily. So first, what is the first postulate given by Vesper theory? According to Vesper theory, the shape of the molecule is determined by repulsion between lone pairs and bond pairs which are present on central atom. So how can we determine the shape? The shape of the molecule depends upon two things. What are they? One is lone pair and another is bond pair. Where they are present? They are present on central atom. So the lone pairs present on central atom and bond pair also present on central atom. If the repulsions between them is more or less, that determines the shape of the molecule. So the shape of the molecule is determined by repulsions between lone pairs and bond pairs present on central atom. So from first postulate we should understand that for any molecule the shape depends upon two things. What are they? Lone pairs and bond pairs. Repulsions between them which are present on central atom. And whereas coming to second one, among these bond pairs and lone pairs which occupies more space on central atom. So among lone pairs and bond pairs, lone pair of electrons occupies more space on central atom. So I am telling you that there are presence of lone pairs and bond pairs on central atom. Among them which occupies more space on it. So among lone pairs and bond pairs, lone pairs occupies more space on central atom. So after that, the electron pairs around the central atom are arranged as repulsions among them are minimum. So I have told you that lone pairs occupies more space on central atom. So how they are arranged? The lone pairs are arranged on central atom as that they are arranged on central atom like the repulsions between them should be minimum, like that they are arranged on central atom. So I have told you in the second postulate as lone pairs occupies more space. Even though they occupy more space, they are arranged on central atom as like that the repulsions between them must be minimum. That is the third postulate. So first is shape of the molecule depends on repulsions between two things. What are they? Bond pairs and lone pairs which are present on central atom. Among bond pairs and lone pairs which occupies more space, lone pairs will occupy more space on the central atom. Third one, what it explains, even though lone pairs occupy more space, but the repulsions between them must be minimum, like that they are arranged on the central atom. So that is the third postulate. After that, what is the order of repulsion? So we have already told you that the central atom contains both lone pairs and bond pairs. So the order of repulsion will be more when the central atom only contains lone pairs. If central atom contains only lone pairs but not bond pairs, then the repulsions will be more. If central atom contains both lone pairs and bond pairs, then order of repulsion will be somewhat less. If the central atom contains only bond pairs, then the order of repulsion will be very low. So what is the order of repulsion? The order of repulsion will be more between two lone pairs. The order of repulsion will be less between lone pair and bond pair. The order of repulsion will be too low between two bond pairs. That is the order of repulsion. So the order of repulsion can be written as like that. And after that, the magnitude of repulsion. So from between which things the repulsion will take place? Between bond pairs and lone pairs. So the magnitude of that repulsion depends upon the electronegativity difference between central atom and bonded atom. So I am telling you that repulsions will be takes place. So what is the magnitude of that repulsions? So how can we calculate the magnitude of that repulsions? The magnitude of that repulsions can be find out or calculated, or it can be determined by the electronegativity difference between bonded atom and central atom. First we will take bonded atom, that is, for example, if you take this is the bonded atom and this is the central atom. Hydrogen is the bonded atom, nitrogen is the central atom. We will take electronegativity of these two for nitrogen and hydrogen. We will make a difference between them. The difference between them which is obtained will represent the magnitude of repulsion. For example, if nitrogen has electronegativity 7, hydrogen has electronegativity 1, 7 minus 1, what we will get? 6. So 6 is the magnitude of repulsions between the bond pairs and lone pairs. In that way, we can calculate the magnitude. So the magnitude of repulsion between bond pairs depends on electronegativity difference between central atom and bonded atom. And after that, if there is a presence of bonds, how the repulsions will be? The order. If there is a presence of triple bond, the order of repulsions will be more. If there is a presence of double bond, the order of repulsion will be somewhat less. If there is a presence of single bond, the order of repulsions will be too low. So these two are very important. The order of repulsion in the case of lone pairs and bond pairs will be like this. The order of repulsion in the case of bonds will be like this. So triple bonds will have more repulsive power, and again after that double bonds, and after that the single bonds. Now we can explain the Vesper theory by taking an example. So I have taken ammonia. So the shape of ammonia, we can write the structure of ammonia like this. According to generally the ammonia is pyramidal in shape with bond angle 107 degrees. So what is the shape of ammonia? Pyramidal. And what is its bond angle? 107 degrees. But according to Vesper theory, or due to repulsions between lone pairs and bond pairs, these are lone pairs. The lone pairs which are the electrons which are present in orbital are called as lone pairs. So the repulsions between lone pairs and bond pairs, these are lone pairs and these are bond pairs. Due to repulsions between them, the shape changes to tetrahedral and bond angle is 109 degrees 28 minutes. This is the difference which can be explained by using Vesper theory. And also I have taken another example, that is water. So here this is the water molecule and the shape is angular with 105 degrees bond angle. Due to repulsions between lone pairs and bond pairs, these are lone pairs and these are bond pairs. Due to repulsions between bond pairs and lone pairs, the shape changes to V shape and bond angle reduces to 104 degrees 30 minutes. So basing on Vesper theory, the shape and bond angle may be changed. Why the shape and bond angle may be changed? They may be changed due to repulsions between lone pairs and bond pairs. So this is all about Vesper theory. So the Vesper theory contains 6 important postulates. The postulates are very important, and I have explained the shapes of ammonia and water in order to explain the Vesper theory. So this is all about the valency shell electron pair repulsion theory.